Hello guys, good morning. You are welcome to my YouTube channel, the Explicit Tutorials, and my name is Tutor Joseph. Please, as you are watching this video, endeavor to subscribe, like, share, and comment. And please do well to hit the notification bell so that when I upload a new content, you will be aware. In today's video, I shall be treating a topic called radioactivity. Alright, today's topic is what? Radioactivity. What is the meaning of radioactivity? Radioactivity means the rapid disintegration of an unstable nucleus to produce a stable one with the release of what? Energy. I recap. I said radioactivity means the rapid disintegration of an unstable nucleus to produce a stable one with the release of what? Energy. Now, this term radioactivity was first discovered by Henry Becquerel. Radioactivity was first discovered by Henry Becquerel, but it was named by his student called Marie Curie. Alright, Marie Curie was a student of Henry Becquerel. So it was Marie Curie that discovered uranium and thorium. Uranium and Marie Curie noticed that uranium and uranium and thorium were highly energetic, and they could produce emissions that could penetrate any substance. It could be opaque, transparent, or translucent. Marie Curie discovered uranium and thorium. He discovered that these radioisotope elements were highly energetic and they could penetrate any substance at all, even opaque substances. Then Henry Becquerel, his discovery led to what is called phosphorescence. Phosphorescence means the process whereby there is emission of light of a certain wavelength. All right, it is the emission of light of a certain wavelength by an object during and after excitation of the wavelength of the light. I said it is what? The emission of light of a certain what? Wavelength by an object during and after excitation of the light of what? Wavelength. That is in of what? Phosphorescence, okay? And that was brought forward by Henry Becquerel. Marie Curie discovered that there were some elements that were highly energetic and they could penetrate any substance, opaque, transparent, or translucent. Marie Curie called these radioisotope elements to be uranium and thorium. She also discovered radium, alright? All these elements are what? Radioisotopic. That is, they can undergo what? Radioactivity. Please take note of that. These two are highly energetic. Alright, they are highly energetic. Take note of that. Now, during radioactivity, alright, during the experiment of Henry Becquerel, there were some radiations that were emitted during the process. There were some radiations that were emitted, and these radiations were not visible to the two naked eyes. Therefore, they are only seen using the following instrument. We have the scintillation and cloud chamber. Alright, so we have the photographic film, and here we have the diffusion cloud chamber. Alright, and 4 we have the Gregor-Muller counter. So these are the instruments that can be used to view the alpha, beta, and gamma particle. Now these particles were invisible, so they can be seen only using this following instrument: the alpha particle, beta particle, and what? The gamma particle. Now let us look at the characteristics of these particles of these what? Radiations. The first one is what? Alpha particle. Now, alpha particle uses what? Helium nucleus. All right. Please take note of that. We have alpha particle. It uses what? Helium nucleus. And of course, helium nucleus is actually H2 4. Alright, so this is what? Helium nucleus. Now, number 2, helium is what? An element in the periodic table. So the alpha particle uses what? Helium nucleus. Take note of that. Okay? It is positively charged. It is positively what? Charged. And therefore, it is deflected towards the south pole of the electric and what? Magnetic field. It therefore means that alpha particle is affected by both electric and magnetic field. Alright? It is affected by both electric and what? Magnetic field. It is positively charged and therefore it is deflected towards the south pole of the electric and what? Magnetic field. Which means that this one is what? Negative. So when it is deflected towards the south pole, you have negative positive, so there's a great attraction. Okay, now it is the heaviest. All of the particles that we emitted, alpha particle happens to be the heaviest of all, and again it has the highest ionization energy. It has the highest ionization energy, followed by beta particle, and finally the gamma particle. So you can say that based on ionization energy, you say alpha greater than beta greater than what? Gamma. Alright, take note of that. So based on heaviness, you say alpha is greater than beta and is greater than what? Gamma. Which means that alpha is the heaviest particle that was emitted. Okay, take note of that. These are based, this one, okay, they are the same thing. So based on heaviness and ionization energy, it's always alpha followed by beta and finally gamma. Take note of that. Okay, it is stopped by a thin sheet of what? Paper. So it is stopped by a thin sheet of what? Paper. A thin sheet of paper. That is how alpha particle is what? Stopped. Take note of that. So number 2 is the beta particle. The beta particle, right? 2. Alright, it uses the electron nucleus. Alright, electron is negatively what? Charged. Therefore means that the beta particle is what? Negatively charged. And therefore it is deflected towards the south pole of the electric and what? Magnetic field. Which means that it is affected by both electric and what? Magnetic field. Take note of that. Which means that electric and magnetic field affect both beta and what? Alpha particle. Now, beta particle is stopped by an aluminium foil. Please take note of that. If alpha particle is stopped by a thin sheet of paper, then beta particle is stopped by what? Aluminium. Okay, and so based on heaviness, it occupies the second position, but alpha occupies the first position and gamma occupies the last position, which means that the gamma particle is the least particle that is what? Heavy. Take note of that. The second one is beta and the first one is alpha. Then based on ionization energy, it is alpha, beta, and what? Gamma. So then based on, okay, alpha particle has the least penetrating power. Okay, based on penetrating power now, okay, that is second penetrating power. Alright, which means that based on penetrating power, we can say gamma has the highest penetrating power, followed by the beta particle, and finally the alpha particle. This one is based on penetrating power, and these two are based on what? Heaviness and what? Ionization energy. So which means that I can say that the gamma particle has the highest penetrating power, followed by the beta, and finally alpha particle. Then which one again? Is there another point I've not given? All right. Okay. So these are the features of beta particle. Take note of that. Take note of that. Okay. So the last one is what? Gamma particle. Gamma particle. Don't forget, alpha particle and beta particle are both affected by both electric and magnetic what? Field. Number 3 is what? A gamma particle. All right. It is neutral. It is neutral. Therefore, it uses what? Neutron nucleus. All right. It uses what? Neutron nucleus. You know, neutron is neutral. It is neither positive nor negative, which means that the gamma particle is what? Neutral. It is neither positive nor negative. Take note of that. It is not affected by any of the magnetic or electric field, which means that electric field and magnetic field do not affect what? Gamma particle. Take note of that. And I told you that it has the highest penetrating power, and it is the least particle that is what? Heavy. The least. All right, the least particle that is what? Heavy. Take note of that. And it is stopped by a, take note of this, it is stopped by a dense lead block. If alpha particle is stored by a thin sheet of paper, beta particle is stored by an aluminum foil, and gamma particle is stored by what? Dense lead block. Take note of how they are stored and order of their characteristics. Take note of that. So we've come to the end of the first part of the topic, which are the various emissions or the various radiations that were emitted during what? Radioactivity. Now, let us now discuss. We have the alpha particle. Now, of course, I told you know that alpha particle uses what? Helium nucleus, and helium has mass number as 4 and atomic number 2. It has mass number 4 and atomic number what? 2. Now, during the release of radon from radium, all right, helium is also what? Released alongside. Helium is also released alongside. This is not only the instance that helium is released, all right. You have numerous reactions that involves the emission of what? Helium. As the class progresses, you get to know those reactions. Now I have radium. I have radium is 224. It has mass number 224 and atomic number 88. All right. Then radium is produced, RON. Radium has mass number 220 and atomic number what? 86. Now, what do you need to complete to balance the equation? We need we need 2 as a figure to complete the atomic number, and that will be what? Helium. 2 plus 86 is what? 88. Then 220 plus 4 is what? 24. So this is a good example of what? Emission of helium and radium from radon. Take note of that. Then you now have the beta particle. Now listen, the release of a negative particle is called negatron. The release of a negative particle, or the negative particle released, is called negatron. And negatron results what? An increase of 1 to its atomic what? Number. Alright? Please, negatron, positron do not affect the mass number. They only have impact on the atomic number. Alright, so I have 614. I have nitrogen 14 plus, I said, positron minus 1 0. So see, a negatron has been what? Released. 7 minus 1 is what? 6. 14 plus 0 is what? 14. So this is what? A negatron. You now also have positron. That is the negatively charged particle released is called what? Positron. So you say, if I have sodium, which is 11, then 22, release neon, which is 10, 22, then plus, alright, there's plus 1 here already, plus 1. So you can see positron, positively charged what? Particle, which means that 10 plus 1 is what? 11, then 22 plus 0 is what? 22. So take note of what I just illustrated. So now that we've established the emission of alpha particle from radon, as well as negatron and positron, let us quickly take there's what we call artificial transmutation. Okay? Okay, before I go into that, let me take nucleus and nuclide. Nucleus and what? Nuclide. Alright, the nuclide nuclide are species, are nucleus species. Nuclide are nucleus species with specific atomic number and what? Specific mass number. I'll recap. Nuclide as a nucleus species with definite or specific atomic number or definite or specific mass number, please. Which means that, for example, I have carbon 6 and I have carbon 12. Now, I now have on that carbon as 614. Alright. The nuclide, the isotopic nuclide of this is what? This. So you can see that these two guys are what? Isotopic, because they have the same atomic number but different mass number. They have different mass number but the same atomic number, and you see that these guys are what? Isotopes, because they have the same atomic number but different mass number. Then we have 6 12 plus now you see that these guys are isobars. They are isobars because they have different atomic number but the same mass number. We can see that the isobars are the opposite form of what? Isotopes. If they have the same atomic number, these ones have different atomic number. If this one have the same mass number, these ones have what? Different atomic number. So entities that have different atomic number but the same mass number is called what? They are called isobars. Take note of that. If I also have something like this, if I have nitrogen as 7, then 14, and let me use and nitrogen 8. Alright, now nitrogen, this different atomic number, different mass number, it therefore means that they have the same number of what? Neutron, and these guys are called what? Isotones. Entities that have different atomic number, different mass number are called what? Isotones, and it therefore means that they have the same number of what? Neutron. Now from these expressions, how do we get the number of neutron? Neutron number is equals Neutron number is equals what? Mass number minus what? Proton number. So neutron number now is equals, mass number here is what? 14 minus 7. I'll get what? Neutron number equals what? 7. The same things apply there. 15 minus 8 is 7. So it therefore means that they have the same number of neutrons. Now, if isotones have the same number of neutrons, okay, it means that they have the same physical properties, because the neutron is responsible for the physical properties of an element, while the electron is responsible for the chemical properties of what? An element. Isotones, the same number of neutrons, and as well as what? Others. Please take note of this. NB, NB, NB. Note below. All right, we have what is called the nucleon. The nucleon is a combination of the proton and the neutron. All right, the nucleon is a combination of the proton and what? Neutron. Take note of that. We can also say that nucleon is also what? The mass number of what? An element. Because the mass number of an element means the proton number plus what? The neutron number. Which of these make up the nucleon? It is proton and what? Neutron. Proton and what? Neutron. Take note of that, please. Okay, when is an element said to be electrically active? An element is said to be electrically active when the proton number is equals what? The electron number. An element is said to be what? Electrically active when the proton number equals what? Electron number. Take note of that. Now, let us now discuss the various active series. We have 3 active series, which are the one, we have the theorem series. Now, the theorem series has a half-life of 1.39 times 10 to the power 9. Alright, so this is the half-life of what? Theorem. After 12 steps of what? Disintegration. Now, this theorem, which is TH, have it to be 232 and 92. Is that not correct? Oh yeah, this is the atomic number of theorem, and this is the mass number of what? Theorem. After 12 steps of disintegration, it produces lead, which is Pb, having mass number 82 and what? So 208. Right. After 12 steps of disintegration, theorem having half-life of 1.39 times 10 to the power 9. After 12 steps of disintegration, it produces what? Lead. All right, this is atomic number as this and mass number as what? This. Nice. Please, this series is also called what? 4n series. Theorem series is also called what? 4n series. Take note of that. Number 2, you now have the uranium series. Uranium series has half-life of 4.5 times 10 to the power 10. 4.5 times 10 to the power 10. Then after this series is also called what? 4n plus 2 series. This series is also called what? 4n plus what? 2 series. Take note of that. Now, after 15 steps of disintegration, what happens? There's what? Emission of what? Lead particle, which is 82 and 206. All right. After 15 steps of disintegration, there's emission of what? Lead, which is having atomic number 82 and mass number 206. Take note of that. It is very, very important. Now, this series I said is also called 4n plus 2 series. Take note of that. Number 3, you now have the actinium series. Now, the actinium series, after 13 steps, take note of that. This one is 13, this one is 15, and this one is what? 12. After 13 steps of disintegration, it produces lead, which is 82 and what? 207. This one is called what? 4n plus 3 series. Alright, 4n plus 3 series. The first one is called 4n series. The second one is called what? 4n plus 2 series. And the third one is called what? 4n plus 3 series. Third position, second position, and of course assume. Okay, now these are the various series that are involved during nuclear reaction. All right, but they also call 4n plus 1 series. There's no this. Please, these series are under natural radioactivity. Natural radioactivity. Alright, natural radioactivity. Now, there's no discovery yet that 4n plus 1 series occurs naturally. That is 4n plus 1 series occurs naturally. No. Alright, there's no natural element that possesses what? 4n plus 1 series. However, elements have been produced through artificial radioactivity, artificial radioactivity, activity. Now 4n plus what? 1 series. A good example is the neptunium. All right, neptunium is an element produced through what? Artificial radioactivity. Okay, it's okay. Artificial what? Radioactivity. Okay, now artificial radioactivity is the type of activity that involves the transformation of an element which is non-active naturally to become what? A active what? Radioactivity. Artificial radioactivity is a process whereby elements that are non-active naturally are made active artificially. Now, neptunium is an example of what? 4n plus 1 series. All right, and I have neptunium is NP23793. All right, so this is the atomic number of neptunium, and this is the mass number of what? Neptunium. Yeah, it's recording. That is 237 and 293. Please, after undergoing certain disintegration, it produces what is called a bismuth. Bismuth is Bi209 then 83. Right, bismuth is produced from neptunium. It has atomic number 83 and mass number 209. Please take note of that. It is very, very important.